Now let's explore Python operators. These building blocks are essential to understand how Python works. In this section, we will cover different kinds of operators used in Python. First one is arithmetic operators. They are the mathematical tools, foundations of the numerical operations. Next, we have the comparison operators, which helps to compare values and make decisions in our code. Logical operators form the backbone of Boolean logic and decision making in Python. Bitwise operators, powerful tools for working with data at binary level, and assignment operators streamline our code by combining operation with assignment. Identity operators helps to understand the object relations in Python, distinguishing between identical values and identical objects. And finally, the membership operations allows to check the presence within the sequences, essential for working with Python's collection. Let's start with the arithmetical operations, the fundamental mathematical tools in Python. These operators include addition, subtraction, multiplication, division, floor division, modulus, and exponential. Each one serves a specific purpose in mathematical operations. Let's see in action. Here we have two variables, x assigns 10 and y assigns 3. See the results of arithmetical operations that I have carried out. Moving on to the comparison operators. These are the tools for comparing values. We have equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Watch how the conditional operators works. We compare 10 with 5. See how the operators works and see the output for better understanding. Now let's explore the logical operators. They are the building blocks of decision making in Python. We have three main logical operators, AND, OR, and NOT. Let's see how they work with Boolean values. With A set to true and B set to false, A and B gives us false. Both conditions must be true. A or B gives us true. Only one condition needs to be true. Not A gives us false, inverts the Boolean value. Next, the bitwise operators, a powerful set of tools that work directly with the binary representation of numbers. The bitwise AND operators compares each bit position and returns 1 only if both bits are 1. The bitwise OR operators return 1 if at least one of the compared bits is 1. And bitwise NOT operator inverts all the bits, returning ones to zeros and vice versa. The bitwise XOR operator returns 1 only if one of the compared bits is 1. The left shift operator moves all bits to left, adding zeros on the right. The right shift operator moves all bits to right, dropping the rightmost bits. Go through the code for better understanding of the bitwise operators. Let's dive into assignment operators, the essential tools that help us to store and update values in Python programs. First, we have the simple assignment operators, the most basic way to give a value to the variable. The add and assign operators combines addition with assignment. Subtract and assign operator lets us subtract and update in a single operation. Similarly, multiply and assign, divide and assign, modulus and assign. See the operators in action with the practical examples for better understanding. Now let's explore identity operators, Python's way of determining if two variables are actually the same object in memory. The is operator checks if two variables refer to exactly the same object, while is not verifies if two variables point to different object in memory. First, we create a list A containing the numbers 1, 2 and 3. Now we assign B to reference A. Here it is interesting, that is B isn't a copy. It's pointing to exact same list A. When we check if A is B, Python returns true. This confirms that A and B are referring to the exact same object in the memory. When we create a copy C using the copy method, this creates a new list with the same values, but it's different object in memory. So when we check if A is C, Python returns false. Next, the membership operators. They are used for the elegant way of checking if a value exists in a sequence. The in operator checks if an element exists within a sequence. The not in operator verifies if an element is absent from the sequence. Here we create a symbol list containing the numbers 1 to 5. Let's check if 3 is in our list. The in operator returns true because 3 is indeed in the one of the elements. Now let's check for 6. Not in returns true because 6 isn't present in our sequence. The membership operators are versatile. They work with list, string, tuple, dictionaries, and sets. Remember, mastering Python operators is crucial for writing efficient and readable code. These operators give you the power to perform complex calculations, make logical decisions, manipulate data efficiently, and write more elegant code.